Hi dears, welcome to my channel. Today we are discussing part B of 9th standard 11th lesson, that is sound. Here up to this extent we have seen how is sound produced and how is sound propagated and what are the characteristics of sound and all we have discussed. Now in this part we are discussing how we are able to hear sound and what all frequency are audible for humans and what are the specialities of infrasonic sound, ultrasonic sound and all. Okay, we are going to know how we are able to hear the sound. When we are saying about hearing the sound, what is the first one which is coming to our mind? That is ear. Ear helps to hear, isn't it? If the ears are not there, sound will not be able to be heard by anyone. So ear is very important and we are going to see the structure of ear and how we are able to hear that. See, I have drawn the structure of ear. Ear is divided into three parts, that is outer ear, middle ear and the inner ear. Outer ear is the one which we are able to touch it. See, the part which we are able to touch is called what? This is called pinna. It will be in the shape of a funnel, isn't it? It is having a peculiar shape, isn't it? It's having the funnel shape. Why the pinna is having this much funnel shape? Because it helps to absorb the sound waves which are traveling in the air. For that purpose, the pinna is projected outward and it is having some funnel shape. Okay. Then when we are putting our fingers inside, we can see a tube-like structure is moving inside, isn't it? The tube-like structure which is seen inside after the pinna is called what? This is called auditory canal. What we are saying it as? This is the auditory canal and it ends in a part. If we are putting our buds inside, we will be able to see to a little extent it will go and at the end it will be striking something. So it is called what? This is called eardrum. This is very delicate part. That's why your doctor may be saying not to put any sharp objects inside our ear, because when we are putting that sharp object, it may cause damage to the eardrum. That's why we should not put any hard object. So what are things are there in the outer ear? Pinna, then auditory canal and eardrum. So then we are entering into the middle ear. Middle ear, just touching the eardrum, there are three bones. They are hammer, anvil and stirrup. What are they? Hammer, anvil and stirrup. It is having some other name in some other books. That is, we can call it again as malleus, incus, stapes. Or the stirrup or stapes is the smallest bone of the whole human body. Stapes. So these three. Can you identify that? This is the hammer shape. This is called what? This is hammer. And then yellow colored something it has been drawn. No? This is anvil and the orange color has been drawn over here. This is stirrup. See, so three things, three bones. What are they? Hammer, anvil, stirrup. Or we can say once again as malleus, incus and stapes. So these are the things. And then after the middle ear, we are entering into inner ear. Inner ear consists of three semicircular canals. There is something which is spiral in shape. This is called cochlea. So what are they? Three semicircular canals as well as cochlea is present in the inner ear. And the cochlea is attached to the auditory nerve. So what all things are there in the inner ear? Three semicircular canals, then cochlea which is attached to the auditory nerve. So these are the main structure of ear. Then now we are going to see how we are able to hear sound when the sound waves are entering into our ear. See, the sound waves, the pinna is the one which catches the sound waves and the sound waves travels through the auditory canal and it reaches to the eardrum. I have already told you that eardrum is very delicate part. So what happens when the sound waves with high pressure is just touching the eardrum, it starts to vibrate. It starts to vibrate. This vibration will be moved to the middle ear. What are the things which are present in middle ear? Three bones are there. They are hammer, anvil and stirrup. So these three bones helps for amplifying this vibration. The sound waves will be highly amplified with the help of the middle ear. Then this amplified sound waves will enter into what? Into the inner ear. When it reaches the inner ear, cochlea is there, no? So this cochlea converts the sound waves into electrical signals. So this is the main function of cochlea. It converts the sound waves into electrical signals and with the help of this auditory nerve, this electrical signals will be moved towards the brain. And the brain interprets what is the sound. Like that, the brain will interpret and we will be able to understand what the other person is talking to us. Okay. So this is how the ear is functioning. So all the three parts are very important, isn't it? Outer ear, middle ear as well as the inner ear. Okay. This is how we are able to hear the sound. Those who are not able to hear the sound clearly, they will be wearing hearing aid, especially old age people. isn't it? So if they are keeping the hearing aid in their ears, it will be much more clearly they will be able to hear the sound. How the hearing aid is working? Let's see. Hearing aid is a battery operated device. It is having a microphone in it and the amplifier also in it and also a speaker. So how is it functioning? Let's see. When we are talking to that person, the microphone in the hearing aid have absorbed the sound waves. So with the help of microphone, hearing aid is able to receive sound. Then the hearing aid converts this sound waves into electrical signals. Then these electrical signals will be amplified with the help of amplifier which is fitted in this hearing aid. Then the amplified electrical signal is again converted into sound waves with the help of speaker in it. Then that amplified sound is allowed to pass to the human ear. Thus, they will be able to hear the sound more clearly. So, this is how the hearing aid is helping the people who are having very feeble hearing. Okay. Now the question is arising. Are we able to hear the sound of all frequencies? No. There is a particular range of frequency. Only to that extent we are able to hear. That is ranging from 20 Hz to 20 kHz. If the sound is produced within this range, we will be able to hear. Human ear are having the capability of hearing sound which ranges from 20 Hz to 20 kHz. So the sound which is below 20 Hz are said to be what? It is said to be infrasonic sound, or we are saying it again as infrasounds. And the sound which are ranging above 20 kHz are said to be what, ma? As ultrasonic sound or ultrasound. Okay, so infrasound, audible range, ultrasound. This is the matter. See, infrasound, audible range, and this is the ultrasound. Many animals like elephants, whales, rhinoceros are able to conversate or communicate within the infra range. We are not able to hear that. And many animals, to say bat, dogs, are able to communicate in ultra range. That also we are not able to hear. Have you read in newspaper that earthquake happened in this place, and in the earthquakes many humans are affected but the animals are not affected because animals have left the place, like that you may have heard. Actually what the thing is, before the earthquake is caused by the tectonic movements which you have learned in social from in small classes itself, isn't it? So tectonic movements which are happening below the earth's crust, this earthquakes are happening. So by the movement of tectonic waves, some kind of sound it will release. It will be in infra range. We are not able to hear that. But most of the animals are able to hear this infra sound. So they will understand that some problem is happening in this earth, in the below the earth. So some earthquakes may happen later on, or within 2 days, or within 1 day, earthquake may happen, like that. The animals may be having that aware. That's why they will escape from this area. But as we are not able to hear this infra range, we are not able to understand the earthquake before itself. Okay. So the ultrasonic sound we were discussing is during night time. This ultrasound is very helpful for the bat. It will produce a sound in ultrasonic range. So what happens is, if any prey is there within a distance, it will touch that prey and the sound waves will be reflecting back. So if it is hearing the sound back within a particular range, it will be able to understand that a prey is there or any obstacle is there, like that. Even though bat is not able to see things properly, using the ultrasound it is able to understand the whether obstacle or prey is there within a small distance. Ultrasonic sound is helpful for human as well. In medicinal field, in industrial field, what are the uses of ultrasounds? We will discuss one by one. Have you heard about echocardiogram? Echocardiogram, ECG. The doctors will be able to understand whether there is any problem for your heart. How they will do? Our heart, nearby the heart, they will keep some stickers like projections, and what they are doing is they are sending the ultrasound over there. And what happens? The ultrasound will go inside the body and it will be reflecting back. This ultrasound will be able to be changed into electrical signal with the help of the machines over there, and by forming the image, by seeing the images which it is making, they will be able to understand whether there is any problem for your heart or not. Okay, so ECG is an easy way for understanding whether there is a trouble in the heart. Have you heard of the another word, ultrasound scan? For the pregnant ladies, the doctors will be having a handheld transducer, and with that they will be touching in the abdomen of the pregnant ladies, and they will be able to see the movement of the baby in the womb. Have you seen How they are doing? The same principle. Ultrasound is allowed to pass through and the reflection will be taken as electrical signals, and from that images can be created with the help of a machine, and by seeing that image they will be able to understand whether the baby in the womb is having any health issues, or if the baby is healthy. Like that they will be able to understand. So in that also this ultrasound is helping for diagnosis of various internal organs and for biopsies, for taking injections. In all these, this ultrasound is helping. Ultrasound also helps to cure the kidney stone. How is it helping? We know that ultrasound is having higher frequency, isn't it? When the forced sound is allowed to pass to the kidney part, what happens? It makes the particle to vibrate. If stone is present, the stone will be vibrating or it will be scattering. It helps for the stone to crack. If it is cracking, if the stone is so small, it will be cracked. Then it will be yet still more smaller. That small parts of the stone will be coming out through urine. By this way, the small kidney stones can also be cracked down with the help of this ultrasound. So you may have understood what all helps this ultrasound is doing in medicinal field. Now coming to the industrial area. In industries, it also this ultrasound is helping for seeing the crack in the metal. If the metal is made of thick solid, we will not be able to find crack if it is present in between, isn't it? So how can we able to understand? A transmitter is fitted to the metal, and this transmitter is making an ultrasound. This ultrasound is allowed to pass through the whole metal. If there is no crack, it will move from the beginning to the end. There will be a detector to detect the sound. If there is a crack in between, what happens? When it reaches the crack, it will be reflected back. This ultrasound will be reflected back. So the detector will not be able to detect the full sound. So we will be able to understand that there is some crack somewhere, and it will be helpful for understanding where the crack is. So we will be able to know whether the crack is present in that metal. Secondly, it also helps to clean the metal parts which we are not able to clean. Okay, how they are able to clean? The same principle. The metal part which has to be cleaned is allowed to put in a liquid. Then ultrasound is allowed to pass through that metal. What happens? Due to the higher frequency, that metal will start to vibrate. When it is vibrating, the dust particles also will be vibrating in some other direction. So this dust particles will be eliminated out from this metal. So the metal, after the particular time interval, the metal will be cleaned. Okay. Yet another important use of ultrasound, that is sonar. Have you heard of sonar? Sound navigation ranging. What is it? How is it helpful? Actually, it helps to find whether there is a hill or valley in the depth, in the basement of the sea, or if there is anything which is immersed in the sea. Titanic ship has been immersed, isn't it? They have been found that Titanic ship is there in this place, like that. They have located that only with the help of sonar. So sonar is very helpful. So what is the sonar? If in a boat or in the ship, this sonar is connected, it is having a transmitter and a detector. Okay, so transmitter makes sound and allowed the sound to pass through the water. So it will be moving with high frequency. The sound waves are there, so it will not be scattered anywhere. It will be moving to a large distance. Okay, and the detector is there. It will detect the reflected waves and it will convert it into electrical signals. From the detector, we will be able to understand whether an object is present in the base. There is a valley or a mountain is present in the basement of the sea and all. How distance of the object which is in the base of the sea is understood by the formula 2D is equal to V into T, or D is equal to V into T divided by 2, where D is what ma? D is the depth of the sea, and V is the velocity of the sound, and velocity, or we can say the speed of the sound also, and T is the time interval. By knowing the speed of the sound as well as the time interval, we will be able to understand in which distance the object is present at the base of the sea, at the sea. Part B is finished. I think you have understood all. We are going to have the question time quickly. Now it is the question time. The first question. If we are changing the feeble sound into a loud sound, we are increasing the dash of the sound. Second one, sonar works on dash sound. Third one, sound of single frequency is called dash. Okay dears, here I am winding up. We can see in the next class. Bye.